In this problem, we are given that AB equal to AD, CD equals to 2 square root 2, AC equals to 6, angle BAD equals to angle BCD equals to 90 degrees. What is the length of BC? So, right now, we are given that two lines are equal, and we're given the exact lengths of two sides, and we're given that two angles are equal. Well, we can start with the angles, because there are actually many ways to solve for BC. And to take advantage of the right angles, well, the first thing that comes to your mind might be right triangles, but there's actually a lot easier method to solve this problem. And first of all, since angle BAD equals to angle BCD equals 90 degrees, so angle BAD plus angle BCD equals to 180 degrees. This might seem obvious, but it's actually very important for this problem, because angle BAD and angle BCD are opposite angles in the quadrilateral ABCD. And if the opposite angles are supplementary in a quadrilateral, this means that the quadrilateral is a cyclic quadrilateral. And there are various properties for cyclic quadrilaterals that we can use. Now, to find side lengths using cyclic quadrilaterals, one of the important theorems that we can use is called Ptolemy's theorem, because Ptolemy's theorems give us the relationships between the diagonal and the sides. But first, we need to construct a helping line, because in Ptolemy's theorem, it requires two diagonals. So we need to connect BD. So, before we write down the theorem, we have to use the remaining information, which is AB equals to AD. Now that we connected BD, we will realize that triangle BAD is a special right triangle, since AB equals to AD, angle BAD equals to 90 degrees. So triangle BAD is isosceles right triangle. So BD equals to square root 2 AB equals to square root 2 AD. This will come in handy when applying Ptolemy's theorem. So, one more step before directly applying this theorem. To make our calculations easier, we can set AB and AD as a variable. Then BD will equal to square root 2x. Then we can apply the theorem. By Ptolemy's theorem, we have AC times BD equals to AB times CD plus AD times BC. If you want to know more about the proof of this theorem, you can check out my other video on my channel on the proof of Ptolemy's theorem. Now we can plug in the values. AC equals to 6, BD equals to square root 2x. So 6 square root 2x equals to 2 square root 2x plus x times BC. Now we can divide by x on both sides, because first of all, x obviously cannot equal to 0 because it's a silent. And then notice that after we divide by x on both sides, we end up with 6 square root 2 equals to 2 square root 2 plus BC. So BC equals to 6 square root 2 minus 2 square root 2. This equals to 4 square root 2. And that is how you solve this problem.